Okay, let me continue the previous lecture. In fact, this is lecture 3 of linear algebra. I defined matrix multiplication. First, I said, let's have a row vector R, which A11, A12, A1n, and a column vector C, B11, B21, up to Bn1. So they have the same number of entries. Now the first one times the first one, the second one times the second one, up to the nth one times the nth one, and then add it together. So R, C as two matrices is A11, B11 plus A12, B21 plus A13, B31, and the J1, for example, is A1, J, B, J1, and the last one is A1n, Bn1. Or you can write in sigma notation that J goes from 1 to N, Aij, A1j, sorry, A1j, Bj1. Okay, now that we know how to multiply two matrices of this form, they should have the same number of terms. Otherwise, if this has less terms than this one, then say for example, if it has n-1 terms, then this A1n goes nowhere, it doesn't multiply by anything. So they should have the same number of terms. So if that happens, you might say, okay, I can define that, then this is redundant. And this last one is redundant. You can just throw it away. Okay, so using this, we can multiply two matrices. So matrix A, I write matrix A in this format, R1 as a row vector. So I just take the row number 1, row number 2, and row number same. So I'm assuming that A is n by n, and B is what? Well, and I write B in this format, C1, the column, C2, the second column, up to C, say, let's say, I don't know, like M, Q, something. Okay, now, I'm going to multiply this by this. R1, C1, R1, C2, R1 up to R1, CQ. And this should have the same number of terms as this. Number of terms here is, in fact, this n. That's the number of terms in any row. So the number of terms in any column of this B should equal to this. So where does it come? N. And number of columns, Q. So number of rows in any column of this is n. Number of columns in any row of this is n. So we can multiply one by one. Okay, so I will do this. I will take this, multiply, and go on. And that will give me the first row. So R1, C1, R1, C2. And there is no plus or anything, it's just multiply. R1, CQ. Then R2, C1, R2, C2, R2, CQ. Up to R. What am I saying? RM, C1, RM, C2, up to RM, CQ. And that is the result. And this matrix is M by Q. So these two are same, and this whole matrix, if let's call it something C, say, then C is M by Q. Okay, so the end result is take this and this. The middle one should be the same, and it doesn't show up in the end result as size of the matrix. So size of the end result is this times this. Okay, let me give you examples here, do some examples so you know what it's I'm doing here. So examples. Erase this thing. One. Let's multiply a simple 1, 2, 3, 4 by well, I can say minus 5 with 2, let's try to do this. So minus 8, say negative 1, say negative 3. No, let's say plus 3. Okay, so it is 1 times 5, negative 5, plus 2 times negative 8, plus 3 times negative 1, plus 4 times 3. So that's minus 5, minus 16, minus 3, plus 12. Okay, 16, 12, that gives a minus 4 here, and minus 9, minus 3 is minus 1. So this matrix or this vector, row vector times this column vector is that. Okay, now let's multiply two matrices. Well, I can extend this and this. So well, let's assume that this okay, so let's take this to be two rows. So let's write 1, 2, 3, 4, 5, 6, 7, and 8. And this one, let's just write a simple number. Minus 1, 2, and negative 3, say 5, and this one, say 8, minus, say 4, and 2, negative, say 5. Okay? So, first of all, let's find the size of the end result. The size of this one is 2 by 4. Size of this one is 4 by 3. So the size of the end result will be 2 by 3. See, the 4 and the 4, they just vanish. So the size of the end result is 2 by 3. Okay? So let's write one by one. This times this, that is R1C1. So that is R1, this is R1, and this is R2. This is C1, this is C2, and C3. So let's divide it here. That's R1, C1, R1, C1, R1, C2, R1, C3, R2, C1, R2, C2, R2, C3, and finished. So Okay, so let's write each one of them separately, and then write over there. And you can see there's 2 by 3. So, well, I know R1C1. R1C1 was minus 12, right? I didn't change that. So the first one was minus 12. Then this R1C2 will be 1 times negative 1, 1 times negative 1, plus 2 times 2, 2 times 2, 3 times negative 3, plus 3 times negative 3, plus 4 times 5. Let me double check. 1 negative 1, 2 times 2, 3 times negative 3, 4 times 5. So I have minus 1 plus 4 minus 9 plus 20. So I have 24 minus 10, that is 14. Double check. So 20 plus 4, that's 24, 9, 1, that's 10, 24 minus 10, that is 14. Okay. So that was R1C2. Now R1C3 is 1 times 8 plus 2 times minus 4 plus 3 times 2 plus 4 times minus 5. So this is 8 minus 8 plus 6 minus 20. So these two cancel out, so that's minus 14. No. So what's minus 14? Okay. So that was R1C3, the third in the first column. R2C1 will be this and this. So I have 5 times minus 5 plus 6 times minus 8 plus 7 times minus 1 plus 8 times 3. So minus 25 minus 48 minus 7 plus 24. Okay. So this 24, 25, that gives me minus 1, that's 49, 49 plus 7, that is 56. 56, so that's minus 56. Let me double check. Minus 1, there's a minus 1 here, that's 49, 49 plus 7 is 56. So R2C1, R2C2. So R2C2 will be 5 times negative 1 plus 6 times 2 plus 7 times negative 3 plus 8 times 5. And now it's saying minus 1, 2, negative 3, 5. So that's minus 5 plus 12 minus 21 plus 40. 40 and 12, that is, this gives me 52. And this one gives me minus 26. Minus 26. That's 26, right? Okay. So that's minus 26, that is 42. There's 52, so minus 26. If I make mistakes, don't just you correct that, because you see I wrote this down on the fly. I'm not writing from notes, so I might make mistakes, which is okay. Well, it's not okay, but I mean everybody makes mistakes. So R2C3 will be 5 times 8 plus 6 times minus 4 plus 7 times 2 plus 8 times minus 5. So that's 40 minus 24 plus 14 minus 40. Okay. So this one and this one cancel out. 40, 24 is minus 10. Minus 10. Okay. So that is the end result. But as you see, if I have a big matrix here, I don't know, like 100 by 200 something, and then the other one should also be big, at least in one dimension. It's not easy to, not easy, it is easy because we are just multiplying and adding or subtracting, something like that. So it's basically the 4 operations. So it's simple, but it is time consuming. And so what we usually do, we just do it on a calculator. Now I don't have a calculator here. I can get one, but it's not easy to show it to you. So my suggestion is you, I guess most of you have at least a TI of some sort, TI 83, 84, TI something. Find the matrix and matrix operation and enter, for example, these two and see how, when you multiply them, or how to multiply them and how to look at the results. Anyway, if you have a laptop or a computer at home, you can use, say, wolframalpha.com to multiply matrices, but be careful how you are entering a matrix in Wolfram Alpha, at least. Check and see if it has understood what you mean. Okay. Well, if you know how to use R or Python or any other programming language, you can use that. You can use, for Python, for example, there is a numerical Python, NumPy, which does all these calculations. It's built in. So if you are familiar with that, you can use that. Okay. So I gave you 2 important examples here. The one thing I didn't discuss was the equality of matrices. So if I have A m by n and say B also m by n, I say A m by n is equal to B m by n if in fact they are the same. If in fact they are the same. That is if and only if Aij equals Bij for all I from 1 to m and j from 1 to n. So when I say if Aij equals Bij, I mean that they're the same. And that's when, if you're solving, say, an equation, you say x squared plus 2x plus 5, for example, equals 0, you're saying that the left side and the right side are the same. Okay? Okay, so this basically means that they are the same. Now, let me, using this, let me multiply a matrix like AMN by a column vector. So let's say B is in fact n by 1. Okay? So I'm multiplying this thing A11, A12, A1n, A21, A22, A2n up to M1, AM2, AMN. And I'm multiplying this by B1, but this is just a row vector, a column vector, so let's just write B. What should I write B? Let me use some other notation here, X. But I have a point from writing X here. X1, X2, Xn. Okay? So, it is row 1 times row 1, row 2 up to row m. Row 1 times, there's just one column, right? There's just one C. So this looks like this. R1, C, R2, C, R3, C up to R, N, C. Right? So that's like, and you can see that it is a column vector, in fact. The result is a column vector, which makes sense. This one is m by n. This is n by 1, so the result is m by 1. So this is m by 1. Okay. And you can see that it has m rows. And so let's look at each one of them separately. So I have this thing. When I multiply, I will get this. A11x1 plus A12x2. Remember, you multiply and add. Plus A13x3 plus plus A1nxn. Then A21x1, A22x2, A23x3, A2nxn. And this goes on, AM1x1 plus AM2x2 plus AMN